So subjective 2, finding the least common denominator. First of all, I'm going to explain it to you. What is least common denominator? A lot of time we write it LCD, right? Least common denominator, LCD, is the product of the most each prime factor as it appears in any of each given denominator. What the hell does that mean, right? Quite a mouthful. It is the product of the most each prime factor as it appears in any of the each given denominator. So for example, let me explain that what the sentence means. For example, if I have, say, I want to find the least common denominator between 12 and 8. Right? So let me write down here. So 12 and 8. Right? What is the least common denominator? Well, what they mean by the product mean of the prime factor, meaning what for the 12, you go into write it as a product of the prime factors. So 12 is 2 times 2 times 3 times 3, and then 8 is 2 times 2 times 2, right? So those are products. So the product of each number, right? The most is prime factor. So for example, number 2, number 2, how many 2 I have? How many 2 I have for the 12? I got, let me highlight in yellow. I got 2 on the 12, right? I got 2 on the 12, and then I got 3 on the 8. Product of the most each prime numbers, most, right? So we're gonna choose the most. We're gonna choose the most. The most will be 3 of the 2, right? 2 times 2 times 2. It's kind of opposite of factor, right? And then the 3. How many 3 do I have? I got 1 3 for the 12, but I got no 3 for the 8, right? But you want to choose the most. You want to choose, so 3, right? One of the 3. So times 3. So together, 2 times 2 times 2 times 3 is did I do something wrong? 4 times 3 is wrong. 2 times 2 times 2, that's 8. 8 times 3 is, no, 8 times 3 is 24, right? So your LCD is 24. So the answer LCD is equal to 24. Okay. So that's according to the definition. All right, so 24, right? So now, for my understanding, I don't even use the definition. In my understanding, this is what I think. You want to find the smallest number that can divide into 12 and divide into 8 at the same time, right? Hence, least means the smallest, right? The smallest number that can divide it into 12 and 8 at the same time. For example, it would be 24 here. 24 here. Now 48 work too, but it's not the smallest, right? 48 divided into 12. 48 is divided into 8, but it's not the smallest, right? So you want to choose the smallest that divide into both numbers at the same time. All right, maybe one more example. For those of you who did not get it, or maybe one more example. I have 8m to the 6n, and then here 12m n squared. Again, if you're good, you can just do things in your head or with your calculator. 8 and 12. I think we already did it here, up here. 24, right? But I'm gonna do it again. Okay. So the A will be 2 times 2 times 2, and then m times m times m times n 4, 5, 6, right? Times n, and then 12 will be 2 times 3. N times n times n. I know it's kind of overkill it, but I want to do it slow. So you wanna pick the ones that have the most prime factors, right? So let's start from smallest. So number 2, the 8 got 3 of the 2, right? And the 12 got 2 of the 2. So you want to pick the one that have more 2s in it. Be 12, be 2 here, 3 of the 2 here. And then for the 3, well, they have no 3, but the 12 have 1 3. So you pick the one that have more 3. That will be down here. For the m, how many m I got? I got 6m, right? So 1, 2, 3, 4, 5, 6, right? And then for n, you want to pick the one at the bottom. That and that. Right. Put them together, LCD is 2 times 2 times 2 times 3 times n to the 6, because I don't feel like writing n 6 times n squared. So that will be 24 m to the 6 and right. Or you can just do in your head, right? 8 and 12, what is the smallest number? Divide it into 8 and 12 at the same time. That would be 24. Right? Part C, I have C and C plus 2. So what the LCD? That divide into C and divide it into C plus 2 at the same time. C plus 2 is not enough, right? C plus 2 is divided into C, but C plus 2 does not divide it into C, right? C plus 2 over C, you cannot, no, I know I told you before, because C being married to the 2, you cannot simplify the C with the C, it'll be wrong, right? So you need one more factor that divide into C. Well, you need one more C outside, right? So C times C plus 2. N squared, thank you, thank you. Thank you. So that means my LCD. Any question? Right. This right here, prepare for you for the big problem. 15b minus 10. Let me write down here 15b minus 10. And I got another one is 15. Right. So let's factor it out. 15b is the same thing as if I can factor between the 15 and 10, it'll be 5, right? So it'll be 3b minus 2. And down here I got 5 or 3 times 5 rather. I got 3 times 5. So what is the LCD? Right? You do the same thing that you do before. You want to pick so I got 5. So the 3, right? So let's start with the 3, right? These are factor here. I got to start with the 3. I got 1 3, right? And then how many, and then another 5, right? And then what else? 3b minus 2, right? 3b minus 2. So my LCD will be 15 times 3b. Yeah, 15 times 3b minus 2. 15 minus 10 is not enough, right? 15b minus 10 is not divided into 15. That's the problem. What about E? Well, x plus 2 is nothing I can do about x plus 2. It's already primed, right? But x squared minus 4. X squared minus 4, I can expand it as x plus 2 times x minus 2. And I'm going to rewrite x plus 2 here. It's nothing I can do. So what the LCD? The LCD will be x plus 2 times x minus 2. Right? Onward, I got x squared plus 7x plus 6, and then x squared plus 4x plus 3. Let's factor them because they're totally different things, right? Let's factor them so you don't want to pick something that's redundant, right? X squared plus 7x plus 6. Two number multiply to 6 and add to 7. 6 and 1. Right? X plus 1, x plus 6. And then x squared plus 4x plus 3. Two number multiply to 3 and add to 4. X plus 1, x plus 3. So what is my LCD? Maybe you guys tell me. You tell me what's the LCD. All right. Thank you. One more. You're missing something. You're almost there. X plus 1, X plus 6, and what else? Yeah, X plus 1, X plus 6, and I write too large. And X plus 3. Maybe I don't need those. Well, you don't want to pick like X plus 3 twice, right? Because you want to pick the most, and they equally the same. The ones for the top, ones at the bottom. W squared plus 2W. No, I don't see anybody. W squared plus 2W minus 3. And then I got W minus 1, and I got 2. Let's factor the top. 2 number multiplied to negative 3 add to 2. W plus 3 and W minus 1. And then let me rewrite these guys. They already prime. Okay. So the LCD, let's see. There's W plus 3, right? There's W minus 1, and there's a 2. You can put the 2s at the front, right? So you gotta get the idea. Right? You get the idea. You try 2. X plus 4. Let me see. X plus 4 over X minus 5 times X plus 7 quantity squared. I already factored for you. 3 over X minus 4 times X plus 7. Right. All right. Last subjective, build rational expression into equivalent expression. So now that you know how to find the LCD, we're gonna use that to add the rational expression that have different denominator, right? So in order to add two fractions, they have to have the same denominator, right? We're gonna use the LCD to fix that. So recall what we did earlier for exercise 3A. I have 1 over 12x squared y and then 11 over 18x cubed y. Right, and then we found that the LCD, you write in blue here, we found that the LCD is 36x cubed y. Right. So now we want to express each rational expression as equivalent expression with the denominator of 36x cubed y. So we want both of these fractions, these two fractions here, have the same denominators, and that same denominator will be 36x cubed y, right? So what do we do? Well, let me write out thing here. 1 over 12x squared y, and then I have 11 over 18x cubed y. Well, we want the first fraction to have the denominator of 36x cubed y. So in order to bring the 12 up into 36, you need to multiply to the 3, right? And then you want the x squared becomes x cubed. You need one more copy of x. And we got one y, so we're good. Right? Now, if you do that, if you multiply something to the denominator, you have to multiply the top by the same number. So 3x over 3x. Basically, you multiply by 1, right? You did not change the expression. You don't want to change the expression, right? So to build rational expression right here, multiply the fraction or multiply it by the fancy one in form of C over C. Right? C divided by C is 1, right? It's just a different kind of 1. Same thing with the bottom, right? You wanna bring up the 18 into the 36, so you need to multiply by 2. You got 3 copies of X and you got 1 copies of Y, so you're good, right? You just need to change the 18. And then you do the same thing to the top. 2 over 2, that's 1, right? So here I have 3x over 36x cubed y, and here I have 22 over 36x cubed y. So far, so good. Right, we just learned how to make things that have the same denominator, right, by multiply by fancy 1. Right? For example, write each rational expression as the equivalent expression with indicated denominator. 5 over 12c, and they want the denominator to be 36c to the 4. So originally we have 5 over 12c. They want what do they want? They want 36c to the 4. That's the new denominator, right? So let's see. I have to multiply the 12 with a 3, right? And I need 3 more copies of c. And I do the same thing to the top. So I don't change my expression. So the top will be 15c to the 3rd, right? And the bottom is 36c to the 4. I checked. Yeah, that's what they meant. For part B, I have, let me write out my original problem, 7x minus 1 over 12x plus 4. That's my original problem. Now, let me tell you, I can say to you that I like the factor form. That's the reason why, right? If I was you, if I can factor it, I would. So what I'm going to do, I'm going to factor the bottom because I see I can factor out the 4, right? So see, I have 7x minus 1 at the top, rewrite it, and the bottom I can factor out a 4. What remains is 3x plus 1. So that's the original in factor form. Now, what do they want? They want to be the new denominator is 12x times 3x plus 1. Right, so what you miss, all you have to do is you just add, not adding, multiplying the things that you missed, right? So you got 3x plus 1. You got 3x plus 1. You missed an x, right? What else you miss? You miss a 3, right? Because you got a 4 there, you got a 4 there, you miss a 3. So 3x, and the same to the top, right? So on the top, I have 3x times 7x minus 1. I'm going to leave it like that. I don't want to bother to distribute. On the bottom is 12x times 3x plus 1. That's what they want, right? We almost there. All right, so I got 4x minus 3 over x squared plus 11x plus 30. And again, I would recommend you factor it first. Right? 4x minus 3, nothing I can factor out there. But the bottom, I can make it into 30. 6 and 5, right? X plus 6, x plus 5. What do they want? They want ax times x plus 5 times x plus 6. So all you do is multiply both top and bottom by ax, right? See how easy that is. Ax when you have in factor form. Any question about this one too? Last one, x minus 5 over x plus 1. nothing I can factor, right? But what do they want? They want x squared plus 4x plus 3. If I was you, I'll factor this. Right? Everywhere you see something you can factor, go ahead and do it. X plus 3 and x plus 1. Okay. So basically what they want is x plus 3 times x plus 1. That's a new denominator, right? What do you miss? You miss x plus 3, so all you have to do is multiply both top and bottom by x plus 3. Right, so that would be x minus 5 here and times x plus 3. Right. Don't bother to distribute it. I think unless they ask you to. Otherwise I'll leave it like that. You try 3. 5 over ax cubed, and the denominator that they want is 24x to the 5th. X to the 5th. You don't have to rush. I extended you try all the way to like tomorrow night or something. All right, if nothing else, thank you for attending the class virtually. Again, I hope you guys do the problem, the list of the problem I announced yesterday. It's important that you do it so you can do well on the quiz. If nothing else, I'll see you on Friday. Okay, stay warm. When you're done, you can leave.